Hey class, good morning. In this lecture on 10.2, we're going to develop and apply the formulas for the area and circumference of a circle. We're not going to spend so much time developing the formula, but really more applying them. And then we're going to develop and apply formulas for regular polygons. So this is an extension of what we've done before as far as area addition. So the first thing we need to talk about is what all these vocabulary terms mean and what it really means. So if I said to you, find the perimeter of a regular polygon, you'd say, oh, a regular polygon, all sides and angles are the same. So if I've got a five-sided figure, I've got five sides, I figure out the length of each side, I multiply it by 5, and I get the perimeter. Right, okay, so a lot of this is already intuitive, and if I said, hey, find the area of a regular polygon, you might say, well, wait a minute. If I just figured out what the area of this little piece is, of this triangle, and I multiplied that by 5, I would get the area of the entire pentagon. And the same thing is true for a hexagon, an octagon, even a square. If you break it into triangles and find the area of each triangle, you can then find the area of the regular figure. So let's go through here and put in some information that we know. So n, n refers to the number of sides. S is the length of a side. And again, the idea here is all sides have the same length in a regular polygon. The central angle is 360 divided by the number of sides. So in this case, DCE, the measure of DCE would be 360 divided by 5. Okay? A radius, okay? What we're talking about when we talk about radius is like CF could be a radius. And what that is from the center of the polygon out to a vertex. So, center to vertex. Let me highlight that. So again, a radius is like, it says CF. So this, right, that is a radius. An apothem is this one, CB. And that's from the center to the side. And again, these are all vocabulary terms, so we're just kind of going over them. Now, wait a minute. The perimeter then, I just said before, was, well, wait a minute, find the length of each side, multiply it by the number of sides. Well, the area, fascinatingly enough, is the area of each triangle, right? Each one of these triangles multiplied by the number of triangles. And it develops a very cool formula. So, I mean, if you want to think about this, the area of this entire figure, well, it's the number of triangles times the area of each. Say that again. The number of triangles times the area of each triangle. And you say, oh, that's 1/2. So I'm looking right here. All right, if I wanted to figure out the area of this triangle here, I would say, okay, 1/2, the base is the side, and the height is the apothem. Now, that's really interesting because isn't n times s, isn't that actually equal to p? And that's where we derive the following formula. And we say, hey, it's 1/2 the apothem times the perimeter. So the area of a regular polygon is 1/2 the apothem times the perimeter. So what in the world does that look like? Well, it looks like this. It says, find the area of a regular octagon with a side length of 4 centimeters. Okay, what that means is this is 4 centimeters. And all the way around is 4 centimeters. What I don't know is I don't know the apothem. And so this is where all these steps kind of come into play. So we're actually going to go through and list each one of these in order, and it'll make a lot more sense. So the first thing is n. How many sides does an octagon have? 8. Right? What is the length of each side? 4. What's the measure of the central angle? Well, it's going to be 360 divided by 8. I better get out my calculator here, and wait a minute, shouldn't that be 36 divided by 8 is divided by 8, 45 degrees. Okay, the next piece, and I'm going to, let me go ahead and draw that. Let me just draw this right here. Let me just go. So I know this angle here is 45 degrees. Now, what's so cool is how am I going to find this little apothem? And let me draw a little apothem. I'm going to go like this. I'm just going to go. And you'll notice what I'm doing is I'm actually splitting that 45-degree angle into two 22.5-degree angles. So I've got a triangle that looks like this. 90, half of 4 is 2, and this is 22.5. And I'm trying to figure out the length of this purple line. Right? So I'm trying to figure out what A is. And again, this is A, apothem. Great word, apothem. Okay, well, to make a long story short, if I know 3 things about this triangle, I can figure out the entire triangle. I know this angle, and that side's 2. Well, wait a minute. I'm looking for this side. I'm standing up here at the 22.5 degree angle. I'm looking for the adjacent side, and I know the opposite. Oh, man. Trig ratios, you got it. The tangent of 22.5 equals 2 over the apothem. Which, to make a long story short, is the apothem equals 2 divided by the tangent of 22.5. 2 divided by the tangent of 22.5. And I say, hey, my apothem is 4.83. See, now I've got the information to go in and figure out, find the area of the octagon. Okay, well, area is 1/2. No, wait a minute. Now I've got all my pieces. Perimeter is equal to n times s. So that's equal to 4 times 8. Switch that up. How about 8 times 4? You get the same answer. 8 times 4, and that's 32. And so now, final step, the area is equal to 1/2 the apothem, 4.83, times the perimeter, 32, times 32 divided by 2, and I get 77.25. Area equals 77.25. Do I have a unit here? Centimeters? Centimeters squared. If you need to, pause the video, go back and look at anything you need to do. So we're going to use this process again. It kind of looks almost like the law of sine or cosine, right? There's multiple steps. You're going to work your way through it. The other thing we're going to do here is we're going to apply circumference and area of a circle. So if you don't already know this, circumference is pi times diameter, or circumference is 2 pi r, and again, 2r, twice the radius, is a diameter. So these things are equivalent. And of course, the area of a circle is pi r squared. So you've been doing this for quite a while, and sometimes we want to leave things in terms of pi. It's kind of like simplest radical form, where You know, the square root of 2 is exact. There's no rounding. Pi is exact. It's an irrational number. It goes on forever. Leaving an answer in terms of pi is an exact way that has no rounding involved. So when you see a problem like this, it says find the area of, this is supposed to be circle A in terms of p. Well, that means pi. That's because my board's all messed up. All right, so this is circle A in terms of pi, in which the circumference is, so C equals 4x minus 6 pi meters. And it says find the area. Okay, well, area equals pi r squared. So what I'm trying to do out of this is figure out what the radius is. Okay, well, substitute the formula here. Circumference equals 2 pi r. And so I'm going to set 2 pi r equal to 4x minus 6 pi. And now I'm going to solve for r. So really, all I have to do is divide both sides by 2 pi. Okay. Of course, pi divided by pi cancels out. And then 4x minus 6 divided by 2 is 2x minus 3. So my radius is equal to 2x minus 3. Now when I plug it in here, area equals pi 2x minus 3 squared. And I can either leave it like that, or I can square it out, find the area of the circle in terms of pi, right? So I can either square that and make a big polynomial, or I can leave it like that in factored form. The next thing we need to do, in my final example here, all right, maybe I'll click like that. Okay, a drum kit contains 3 drums with diameters of 10, 12, and 14. Find the circumference of each. Well, let's find them in terms of pi, and then as a number rounded to the nearest hundredth. All right, well, circumference equals 2 pi r, or pi times diameter. And I'm given the diameters, so really, wait a minute. I've got a 10 pi drum, I've got a 12 pi drum, and I get a 14 pi drum, inch, right? Inch. And if I wanted to convert this to, rounded to the nearest tenth or hundredth, all I would do is 10 times pi, and I get 31.42. And again, 12 times pi, and I'm using the pi key on my calculator, and I get 37.7. And I get 14 pi, 43.98 inches. And that is the extent of this lesson. Basically, once you have the formulas, this stuff involving finding the area of regular figures has multiple steps, but please make sure this problem's in your notes. You can work your way through it. You're going to use special right triangles or trig ratios to find the apophthegms in most cases. And also, when it comes to area and perimeter or circumference of a circle, we have to think about going in both directions, whether we're given a radius or trying to find it. And that's kind of the big lesson there. All right, stay tuned. Do your problems that I've assigned on Canvas, and stay tuned for the next lectures on composite area and estimating area.